Today's session will focus on a new section, security, privacy, and data integrity. You should be able to explain the differences between the terms security, privacy, and integrity of data. You should show appreciation of the need for both the security of data and the security of the computer system, which might mean two different things. You should be able to describe security measures designed to protect computer systems, ranging from the standalone PC to a network of computers. And these include user accounts, passwords, authentication measures, techniques such as digital signatures, firewall, antivirus software, anti-spyware encryption, and more. You should be able to show understanding of the threats to computer and data security posed by networks and the internet. You should be able to describe methods that can be used to restrict the risk posed by these types of threats and describe security methods designed to protect the security of data as well. So hopefully we're going to be looking at all of these things. Let's look at a few key terms. So do pause the video and jot these key terms down. You need to know about data privacy, data protection laws, data security, what's meant by user account, authentication measures, access rights, malware, firewall, anti-spyware software. I'll not be going through each one of these today because a lot of these should be familiar to you from IGCSE and previous experiences. The next set of key terms that you see on screen talk about encryption, biometrics, hacking, malicious hacking, and ethical hacking, the difference between both of those, phishing, farming, and something called DNS cache poisoning. Ethical hacking is probably new to you, so let's look at that. Hacking used to test the security and vulnerability of a computer system. The hacking is carried out with the permission of the computer system owner. For example, a company that might ask you to identify the risks associated with their particular computer system. DNS cache poisoning is basically altering the IP address of a DNS server by a farmer or a hacker with the intention of redirecting a user to a fake website. So instead of poisoning your computer or installing malware on your computer which redirects you to a fake website, they actually poison an entire DNS cache server. So whenever somebody wants to go to perhaps a bank's website, they get redirected to a fake one. Very difficult to do, but it's becoming more and more common these days. Let's start by looking at data privacy. Data stored about a person or an organization must remain private, and unauthorized access to the data must be prevented. Data privacy is required, and this is achieved partly by data protection laws. These laws vary from country to country, but all follow the same 8 guiding principles, which you see on screen. Now, you need to be familiar with these principles, so please make sure you pause the video and jot these down. Do you need to know all 8 of them? No, you don't, but at least 4 or 5 would be crucial. So please jot those ones down. Please try to remember the ones that are easy to remember. Data must be fairly accessed and lawfully processed, must be accurate, must not be kept longer than necessary, must not be transferred to another country unless the country has adequate protection, must be kept secure. So most of these are pretty straightforward. Now, preventing data loss and restricting data access is critical for data security. So it refers to the methods used to prevent unauthorized access to data, as well as to the data recovery methods if data is lost in the first place. Now, user accounts are the most common ones. You've seen them at school, you must have seen them at home, in games that you take part in, on social network sites. They're everywhere. User accounts are used to authenticate a user, which basically means to prove that a user is who they say they are. And user accounts are used on both standalone and networked computers in case the computer can be accessed by a number of different people, especially in schools. This is often done by a screen prompt, like the one that you see on the right hand side of the screen, which prompts for a username and password. And user accounts control access rights as well. Who gets read access, who gets read and write access, things like that. Very basic form of security, but not the best. And passwords tend to be cracked pretty easily, as the next video shows.
Joshua.
Can't be that simple. Wow.
What?
We got something. We're in. It thinks I'm Falcon.
A clip from one of the old movies called War Games and how easy it was to crack Professor Falcon's password by just remembering that his son's name is Joshua. Now, user passwords is quite important because they allow us to restrict access to data or systems. They should be hard to crack and change frequently to retain security, but a lot of people don't bother changing them often and use the same password for all their different websites or accounts. Now, passwords can also take the form of biometrics nowadays for enhanced security because they are unique to you. However, it's important that passwords themselves are protected, and you can protect your passwords by running anti-spyware software to make sure your passwords are not being relayed to someone else. You should regularly change them in case somebody has seen them over your shoulder illegally or accidentally, and make sure passwords are difficult to crack in the first place. And most people don't bother, as was the case with Professor Falcon. On screen, you see a few suggestions, and I think you've seen these as part of many websites out there that ask you to put in strong passwords, capital letters, numerical values, or other symbols like @ and so forth, or 8 characters minimum requirements. All of these are part of strong passwords, and you need to be able to suggest these if asked in an exam question. Now, digital signatures are used to protect data by providing a way of identifying the sender, for example, of an email. And that's all we're going to talk about digital signatures in this particular section, because all you need to know is that it's a certificate which is granted to a particular user, and a third party is used to verify their identity, just like an SSL certificate for a website. A firewall, on the other hand, can be a better device for protection. A firewall can be software or hardware. It sits between the user's computer and an external network, such as the internet, and filters information in and out of the computer or the network. This allows the user to decide which type of communication to allow with an external source, and it warns the user that an external source is trying to access their computer if they don't meet the required guidelines, or if they're not listed in the allow list. Firewalls are the primary defense of any computer system to protect from hacking, malware, for example, viruses and spyware, phishing and pharming. The diagram that you see on screen kind of represents that: your user's computer, firewall, which can be software or hardware, and the internet. Now, software firewall are part of operating systems, so they are utility software, and hardware firewalls are often more secure, but they are separate pieces of hardware that physically sit between networks. For example, the school would probably have a hardware firewall. The software firewall probably will be used for a particular user's computer. So if you're an individual or you want to protect your own computer at home, chances are that you're probably going to be using a software firewall. And if you're going to protect a bigger network, chances are you're going to be using a hardware firewall. Now on screen, you will see the different type of tasks a firewall can perform. They can examine the traffic between the user's computer or an internal network and a public network such as the internet. They can check whether incoming or outgoing data meets a given set of criteria. They can block the traffic if the data fails to meet the criteria, and they can also give the user a warning that there may be a security issue. They can log all incoming and outgoing traffic to allow later interrogation by the user. They can prevent access to certain undesirable sites. The firewall can keep a list of different IP addresses which are blocked. They can help prevent viruses or hackers entering the user's computer if they are on that particular block list. They can warn the user if some software on their system is trying to access an external data source. The user is then given the option of allowing it to go ahead or request that such access is denied. So any outgoing transmission first has to pass through the firewall. And if the user changes their setting to say, well, okay, whenever something goes out of my system, let me know, then they will have to physically approve it. Now, the firewall can be a hardware interface which is located somewhere between the computer and the internet connection. In cases, it's often referred to as a gateway. Alternatively, it can be a software installed on your computer, as we talked about it earlier, as part of the operating system. The firewall cannot prevent potentially harmful traffic. Okay, so you can't say that a firewall can prevent viruses or hacking, because what could happen is that your password could be very weak, or you put in a USB with a virus on, bypassing the firewall. So a firewall can't 100% prevent all harmful traffic, but it can reduce the risk. Now, do remember, a firewall cannot prevent individuals on internal networks using their own modems to bypass the firewall. Think about VPNs and hotspots. It can't control employee misconduct or carelessness. For example, poor passwords, or as we were saying, putting in USBs which are not scanned or which might have viruses in, or opening email attachments which are not very secure. It cannot prevent users on standalone computers from disabling the firewall as well. These issues require management and personal control to ensure firewalls can work effectively. So training guidelines and monitoring policies and access logs come in handy here as well. Antivirus software is part of data security as well, because running antivirus software in the background on a computer will constantly check for virus attacks. Although there are different types of antivirus software that can work in different ways, they all check the software or files before they are run or loaded onto a computer. And they compare possible viruses against a database of known viruses which have virus definitions. They carry out heuristic checking, which basically means checking the software for behavior that could indicate a virus, which is very useful if the software is infected by a virus which is not in the database. They can quarantine files or programs which are infected and allow the virus to be automatically deleted, or allow the user to make the decision about deletion, because sometimes heuristic checking can result in false positives where a file could be identified as a virus but it isn't exactly a virus at all. Antivirus software needs to be kept up to date since new viruses are constantly being discovered, so that's another issue related to antivirus software. Full system checks need to be carried out regularly as well. These need to be scheduled, for example, once a week, since there are some viruses which can lie dormant and would only be picked up by this full system scan. So a lot of things need to be considered to make effective use of antivirus software. It's not just a simple matter of installing it and then forgetting about it. Anti-spyware software detects and removes spyware programs installed illegally on a user's computer system, so they act in a similar fashion as antivirus software. And this software is either based on rules, it looks for typical features associated with spyware, or based on known file structures which can identify common spyware programs. So heuristic checking and false positives are also effects of using anti-spyware software. Anti-malware software works the same way as anti-spyware software, so sometimes they're known as different names, but they're exactly the same thing. They just look for different patterns and they suffer from the same issues that antivirus software suffers from. So pretty easy to answer these type of questions in an exam. Encryption is the next thing. If data on a computer has been accessed illegally by a hacker, for example, it is possible to encrypt the data in the first place, making it virtually impossible to understand without encryption keys to decode it. And this cannot stop a hacker from deleting the files, but it will stop them from using the data for themselves. So it's an essential part of data security to have encryption a part of your tool set. Another key component is biometrics. In an attempt to stay one step ahead of hackers and malware writers, many modern computer devices now use biometrics as part of their password system. And biometrics rely on unique characteristics of human beings. Examples include fingerprint scans, retina scans, basically which involve pattern of blood capillary structures, facial recognition, and voice recognition. You should be familiar with quite a few of these because they are part of modern smartphones, but you need to go into a bit more depth when you're answering these. Fingerprint scans. Images of fingerprints are compared against previously scanned fingerprints, which are often stored in a database. If they match, then access is allowed, and the system compares patterns of ridges and valleys, which are fairly unique, and accuracy is about 1 in 500. So your thumbprint or your fingerprint might have ridges and valleys, which you can quite clearly see in the image, and these are compared, and if they match, access is granted. Retina scans use infrared to scan the unique pattern of blood vessels in the retina, at the back of the eye basically. It requires a person to stay still for 10 to 15 seconds while the scan takes place. It is very secure since nobody has yet found a way to duplicate the blood vessel patterns, and accuracy is about 1 in 10 million, so you'll probably see that as the gold standard to a certain extent. And of course, you have other types of scans like voice recognition and facial recognition, which work in the same way as fingerprint scans, where samples of your voice or images of your face are stored, and They are then compared, and if the pattern matches, then you are allowed access. Now, of course, there are risks to the security of stored data. Hacking is one of the most common ones, and there are two types of hacking: malicious and ethical. Malicious hacking is the illegal access of a computer system. This is normally without the user's permission or knowledge, and it is usually employed with the intention of deleting, altering, or corrupting files, or to gain personal details such as bank account details from the user. Strong passwords, firewall, and software which can detect illegal activity all guard against hacking. The other version of hacking is ethical hacking, which is authorized by companies to check their security measures are effective and how robust their computer systems are to resist hacking attacks. It is legal and is done with the company's permission, and a fee is paid to the ethical hacker as well. Now, other forms of risks include malware, which is one of the biggest risks to integrity and security of data on a computer system, and many software applications sold as antivirus software are capable of identifying and removing most of the forms of malware that you see on screen. Viruses, for example, are programs or code that can replicate and or copy themselves with the intention of deleting or corrupting files or causing the computer to malfunction. They need an active host program on the target computer or an operating system that has already been infected before they can run. Worms, on the other hand, are a type of standalone virus that can replicate themselves with the intention of spreading to other computers. They often use networks to search out computers with weak security, and their goal is to infect as many computers as possible. They can be mischievous, they can also lead to corruption and a whole host of other security issues. Logic bombs are code embedded in a program on a computer, and when certain conditions are met, such as a specific date, they are activated to carry out tasks such as deleting files or sending data to a hacker. Trojan horses are malicious programs often disguised as legal or legit software. They replace all or part of that software with the intent of carrying out some harm to the user's computer system. And then you have bots, which are basically internet robots, not always harmful, and these can be used, for example, to search automatically for an item on the internet. However, they can also cause harm by taking control over a computer system and launching attacks, especially as part of a DDoS attack. Spyware is software that gathers information by monitoring, for example, key presses on the user's keyboard. This information is then sent back to the person who installed or sent the software, who can then identify patterns and use those to gain access to secure accounts and so forth. This type of software is also known as key logging software. Now, another key risk is phishing, where legitimate looking emails are sent to users. They may contain links or attachments which, when clicked, take the user to a fake website, or they may trick the user into responding with personal data such as bank account details or credit card numbers. The email often appears to come from a trusted source such as a bank or a service provider. The key is that the recipient has to carry out a task, click a link, for example, before the phishing scam actually causes harm. Now, these are genuinely very easy to detect. You can look at the source email, look at the kind of information that's in there, whether you're being pressed for time, and you can avoid putting yourself at risk to these type of phishing scams. Now, on screen, you'll see a number of ways to help prevent phishing attacks, so do pause the video and jot these down. Users, especially in industry or commerce, should undergo frequent security awareness training to become aware of the new types of phishing scams, because these happen all the time. Of course, you should not be clicking on links unless you're certain that it's safe to do so. It's important to run anti-phishing toolbars on web browsers. These are becoming more and more common. Look out for HTTPS or the green padlock symbol. Check online accounts frequently. Change passwords as well. Ensure an up-to-date browser with all the security updates and upgrades. Make sure that your firewall and your anti-malware is updated as well. Be wary of pop-ups. Use the web browser to block them automatically. These are just some of the ways that you can help prevent phishing attacks. Of course, phishing isn't the only risk that is common these days. Pharming is another approach. Pharming is malicious code installed on a user's computer or on a web server. The code redirects the user to a fake website without their knowledge. The user does not have to take any action, unlike phishing, where you need to click a link. The creator of the malicious code can gain personal data such as bank details from the users, Often the website appears to belong to a trusted company and can lead to fraud or identity theft. So why does farming pose such a great threat to data security? Well, we already know that farming redirects users to a fake or malicious website, but this redirection can often be done using something called DNS cache poisoning. So not just by installing malware on a user's computer, but we can actually poison a DNS server. Now, every time a user types in a URL, their web browser contacts their DNS server. The IP address of the website is then sent back to their web browser. If we do DNS cache poisoning, that changes the real IP address value to a fake website's IP address. Consequently, the user's computer connects to the fake website, and that basically means that we just don't need to deceive one particular person. We could deceive an entire community, an entire network of people that connect to a DNS server, and that means we can cause fraud on a massive scale. Farmers can also send malicious programming code to a user's computer as well, install viruses and further malware. The code is stored on the hard disk drive without their knowledge whatsoever. And whenever the user types in the website address in the future, the malicious programming code will alter the IP address and send back to their browser, which redirects it to the fake website. So there's no way out of this particular loop. A phishing attack is an email sent to you. A farming attack happens all the time. So there's no way out of it. Quite dangerous. Now, it's possible to mitigate the risk of farming by using antivirus software and anti-malware software, which can detect unauthorized alterations to a website address and warn the user, using modern web browsers that alert users to farming and phishing attacks, checking the spelling of websites, checking for HTTPS and or the green padlock symbol in the address bar. It's more difficult to mitigate risks if the DNS server itself has been infected, and that's unfortunately very difficult because it's out of the hand of the end user. You do not have any control over the DNS server. The only thing is that if you manage to spot that the website is fake, you need to raise an alert to the actual website, and then they can perhaps contact a DNS server and make things change or investigate. Now, the final part of this particular section is data recovery, and data can be lost accidentally or it can be deliberately lost due to attacks. So let's look at accidental loss of data first. If you accidentally lose data, for example, a file is deleted, backups can be used to restore it. So that's one key way of recovering data. You need to ensure that you're saving data on a regular basis for the backups to work. And of course, user IDs and passwords, access levels can be used to restrict users, so only authorized users can delete files and not everybody can. That can help in preventing accidental loss. And of course, you can have data loss due to hardware faults, such as a head crash on the hard disk drive. In this case, backups come in handy as well, using things like uninterruptible power supplies or USPs. In case there's a power loss which causes hardware malfunction, they can come in handy. Saving data on a regular basis is another way, as is the use of parallel systems as backup hardware. So if the main hardware fails, the parallel system can take over. Software faults, for example, incompatible software installed on the system, can also lead to data loss. And in this case, use of backups is also very useful, along with saving data on a regular basis. So in case the software suddenly freezes or crashes, the user can recover. Incorrect computer operation is another key way of losing data. For example, shutting down the computer while you're saving or removing a memory stick. Again, backups come in handy here, along with correct training procedures, so users are aware of the correct operation of hardware. So you simply don't shut things down while you're saving. So since backups is such an important measure to prevent against data loss, let's look at that in a bit more depth. Now, despite all the best protection, data can still be lost or corrupted. And in all cases, backing up of data regularly, automatically or manually at the end of the day onto another medium such as cloud storage or removable hard disk drive is key to data recovery. The backup should be stored in a separate location in case, for example, a fire or an office break-in. Somebody should be given the role of carrying out backups to ensure it is always done. Backing up data, though, may not be a suitable method of recovery in the case of virus infections, as the backed up data may contain strands of the virus which could reinfect the clean computer upon recovery. So it doesn't work in all situations. For exam questions, you need to know about the different locations, the different mediums, and you need to make sure that backups are scheduled at different times. So you might have depending on the need of a particular organization, you might have a backup at the end of a day, end of a week, or you might have backups which are continuous. Now, hopefully, by the end of this lesson, you know what is meant by data privacy. You can list 4 main principles of data protection at least. You can describe 4 types of malware. What is the difference between phishing and pharming? What is meant by DNS cache poisoning? What can we do to prevent data from being lost from a hardware fault or accidental loss or software fault and so forth? And you should be able to identify and describe for a particular context what the best way of backing up data can be. That's all for today. If you got any questions, as usual, please send them my way. I'll see you in the next lesson.